Okay, we're recording now, so we should be good to go.
All right. Welcome everybody to meetup number 129 of the DoK. Today I took the seat of Bart, and I'm very happy to be here. Thank you, Bart, for letting me host this operator panel. Today we are welcoming 3 of our members. Please welcome Sergey, who is the group product manager at Percona. We have Julian, who is the CEO at Anynines. And we have Nick, who is principal developer advocate at Ondat. Welcome to the 3 of you.
Thanks.
So today we are going to speak about operators. It's fairly hot topic in the data and Kubernetes community. The operator pattern for Kubernetes actually came up in 2016. So it's quite an old concept. Yet I feel only in the last maybe 2 years, the tool has really started to come up in conversation and be quite a hot topic. So we are going to start the conversation by really trying to understand what's an operator and what can you do with that. So my first question, and Sergey, let's start with you. Can you share your opinion, like your take on what is a Kubernetes operator?
Yeah, sure. So Kubernetes operator is a piece of code that helps users to automate the deployment and what's more important, I believe, is management of the applications on Kubernetes. For databases, it means that you can deploy your database on Kubernetes with YAML manifests, right? Saying, hey, I need this container, I need this pod, and somehow interconnect everything together. And then you need to configure your database so that it forms a cluster or something. And then to take a backup, you need to come up with some backup tool that is going to connect to your database and so on. But instead, you can use an operator, which is going to do all the heavy lifting for you. So you don't need to do anything manually. You just say, hey, I need a cluster. I need this number of nodes, and I need to expose it like this. You get a cluster, you get a service, it's up and running in a decent amount of time. You don't need to spend any time of yours. And then you have an access to day 2 operations, which means you can scale your cluster easily by just saying to Kubernetes API, hey, Kubernetes, I want more nodes to my database cluster. Please do this for me. And Kubernetes does it for you through the operator code. And you can take the backup, you can perform upgrades through the operator, and many more, right? It depends on the operator capability, and if it is mature enough, you have more and more use cases you can cover.
Very interesting thank you for the answer, Sergey, and very interesting about the more use cases. Actually, Solomon Hykes, who is the founder of Docker, wrote an interesting tweet about operator. I'm quoting him here. He said that Kubernetes, similarly to Docker, was not designed to be a platform, but more an extension of the Linux paradigm. And so he says that even like now, like this, the Kubernetes kind of extending this paradigm. And he says that they can be programmed with micro platform called operators. But yet, like if we look at, so I think what Solomon here say, like it's pretty wide in terms of Sergey's answer was very focused on database, obviously, but because that's his job. And we are speaking about stateful workload at data and Kubernetes, but I think it's interesting also maybe to consider this operator perhaps as something more. But it sounds like that might not be the case. Like the chief architect at SUSE, Darren Shepherd, also voiced his opinion about that, saying that basically the only time that you really need to write an operator is for custom orchestration logic. for persistent system. I'm quoting him here. I'm going to share all of this link in the chat if you want to check them out. For systems that are highly available. So obviously, persistent system like databases is what's needed. Julian, like, what's your take on operator? And what do you at anynines, like, what do you use them for?
Yeah, so I agree with all that's been said before, but I would take another angle. It's two perspectives, I would say. First of all, what operators are usually used for is one aspect of it, and the other what it actually is as a concept. First of all, the concept of operators has helped the acceptance and spread of the on-demand provisioning of dedicated service instances as a pattern, which, for example, we at anynines apply since 2013 based on a declarative technology called BOSH that comes from the Cloud Foundry ecosystem. Now, I'm very happy to see that this paradigm actually has been brought into the Kubernetes ecosystem where it becomes more popular. And that's all about how to manage databases in a cloud native way. So it's very important to see that this topic is not necessarily identical to the operator topic, and that operators is just technical means on how to make that implementation possible. When it comes to operators, it boils down to, well, let's say more or less custom CRDs, so custom resource definitions in Kubernetes, as well as controllers. So I think when I think about operators, I also simultaneously think about Kubernetes as becoming a standard API to create declarative workloads. And the operator paradigm is one way to implement the CRDs and describe them, as well as to have a foundation to write operator code that makes something out of that persistent declaration that the CRD will teach Kubernetes to do. And if you then start operating the lifecycle of databases, you'll also see that there are some restrictions to this paradigm. For example, the reconciliation of external resources that are represented within the Kubernetes cluster as, let's say, custom resources, but actually run somewhere else or within a container and not directly a Kubernetes native object, so to say. So to me, all of that is Kubernetes operators. But if I had to choose on one definition, I would say it's CRDs plus controllers, and its primary purpose is to make higher level degrees on high abstractions in Kubernetes that will then be translated into other Kubernetes resources that are of a lower abstraction layer.
Thank you, Julian. And yeah, like maybe taking a step back, what's interesting is that Kubernetes was first developed to mainly handle stateless workload. And then gradually people started to love Kubernetes as this platform and API for hosting any sort of computing workload. And people were like, wait a second, I need my data on there. And so I think that the technology and the community has evolved towards this. And there are a few words that came often, Julian, in your answer, the word translation and declarative. And I think generally the community want more and more ways to shape their infrastructure with declarative, in a declarative way. Nick, like what's your opinion on that? Like, do you agree with what I just said? And do you think there is more to be done to get our system to be more declarative?
Yeah. So actually, to begin with, I believe what Solomon kind of intended to say is that probably Kubernetes, I mean, for me, is also becoming the new glibc, right? So we are moving the abstraction, the abstraction layer. So now we know you're using Kubernetes, and a lot of people say, yeah, we know that everyone will adopt Kubernetes when Kubernetes will be boring. So I guess the goal for everyone is that Kubernetes becomes just boring, right? We want to reach the point where you don't think you're running in Kubernetes. We're not there yet, right? There's a lot of things to do. But if you start with this idea, I like to think that operator, of course, everything that was mentioned is absolutely right. Fully agree with it. I mean, its goal is to encapsulate some intelligence into a declarative format and some code with the controller, like the business logic, all of that. And it's great. It allows you to do things very easily, copy paste at the speed of light, right? And that potentially an issue when you have to troubleshoot, but that's another, you mentioned lack of standard, etc. That's part of it. But where I'm going is that I like to think of Kubernetes without thinking about like only running application. I like to think about Kubernetes itself as an automation platform, and operators, what it allows you to do is to automate the automation. So if you look, back, we had Puppet, Chef, Ansible, Terraform, but now you have things like Upbound and Crossplane, right? This kind of things where by extending, and I agree with Julian, like the main thing is about extending the API in Kubernetes. Well, ultimately, it's not about extending the Kubernetes API, it's just extending the Linux API so that you can, instead of having to write complicated Terraform scripts, well, you have YAML and you have the controller. So you can do pretty much whatever you want within the limits of the Kubernetes abstraction. Things like, provisioning and representing external object like a AWS instance or Azure instance or anything you can think of, you can bring this in Kubernetes and leverage all the benefits, which are distributed system, scale, elasticity, run anywhere, cloud agnosticity. So yeah, the goal is really to get it not as a platform, but just as an extension of the Linux kernel, like the new glibc. But I still think like there's a lot of work to be done there. Maybe at some point, even for specific use cases, abstracting the notion of operator, like database, they all have commonalities. Like storage capacity is storage capacity, replica is replica, sharding is sharding. So if we could start by having the same like naming conventions and the same path in the different resources, or have a tool that can do that for you, that would be great, because then it allows like any company, any project, or any vendor, or any open source project to start building things on top of that. So, okay, you want to do database as a service. Okay, you can build something on top of this abstraction, not on top of the operator, but on top of the abstraction that is defining how a database should behave, right? So now as a project, you can, okay, whether it's Postgres, whether it's MySQL, Cassandra, it's the same terminology, the same workflow, these kind of things. And then later on, of course, the other angle is just you use the operator pattern as an automation engine. Yeah,
that's a very good point. And if you allow me to
please, Julian,
connect to that. I've spent quite some time in the Cloud Foundry ecosystem, and there we had the Open Service Broker API as a standard on how to represent, well, let's say in the 12-factor manifest language, backing services. And we not only had the idea there of service instances, which again led to the paradigm of on-demand provisioning of dedicated service instance as the main paradigm, but also service bindings, which is an abstraction on how to connect an application to the data service. In Kubernetes, obviously, this involves creating a secret, but it also means that you have to create, let's say, a user with appropriate credentials within the service instance. And that is something that currently in the Kubernetes ecosystem, there is no widely spread standard to make that possible. In our operators, for example, we added the notion of service bindings because we want to deliver a more comprehensive perspective on using a database than just to create, the database instance itself. And that is one example on how you need more custom resource definitions to make the life of a database fully automated than just to represent the sheer existence of a database cluster. And it goes back to the question of Kubernetes custom resource definitions and all what they can all do, including reconciliation of non-Kubernetes resources, for example, such as a database user.
Thanks, Julian. So Julian just shared an example of how at Anynines they are using operator in their products. I'd like, and Sergey, maybe you can start, if you could share with the audience one of the reasons why, within one of the Percona product, like what's one use case where you have to use an operator that you could share with us?
You're saying where you have to use the operator?
Yeah.
Well, I cannot think of have used the operator, right? Because I don't believe there is any kind of enforcement there. You're free to choose your own tool. But I would say that in Percona, we see that lots of big companies, enterprises, they are using operators to build their own database as a service. So they kind of using currently something. Let's say they have their own scripts to provide databases for their developers or for their applications on the fly. Or they're using something like Amazon RDS, but they are not happy with the pricing, or they are not happy with the flexibility and some capabilities. They're missing them. And they're starting to research, okay, what can we do? What are the ready-to-go solutions that are available in the market? And they usually figure out, okay, we already have Kubernetes running some stateless applications. So what if we try running databases there? Oh, look, there are operators that are actually providing you a service. So you just deploy it, you have a database up and running. And that's, I believe, the most common use case that we see. And definitely the feedback that we get is they can speed up the provisioning of the database greatly. It's extremely easy to integrate the existing infra as a code tools like Terraform, Ansible, whatever, with Kubernetes, because you already have Kubernetes API. It's CRDs are there, CRs are there. You don't need to change a lot of your code base, and that's it. They can get it up and running in days and have all the flexibility and the functionality they need.
Thank you. According to the survey that we had, we surveyed over 500 organizations, and I will paste the link to the Day on Kubernetes report. We asked the end user why they were using operators. 50% of them say that they use operators to simplify management in a multi or hybrid cloud environment. They also use them for scalability and improve the application lifecycle management. 45 of them say that they use them to automate operation for stateful workloads. So indeed, as Sergey said, you don't have to use operators, but there is some reason to not use them, and we are going to speak about them later. But you should probably use them, right? You don't want to reinvent the wheel. So before we move on, Nick, I'd like to hear from you on what, briefly, if you could describe why you are using operator at Ondat.
Yeah, so operators is, for us, we want to promote this idea of shifting left. So the ability for developer to quickly test their code for, around stateful application. So having the same experience, whether you're in production in the cloud or on-prem, or you want to start developing and test early, like on your laptop, have the same features, but most importantly, that are Kubernetes native. So if you want to enable encryption to do some performance test or enable replication or do anything, Kubernetes doesn't provide this thing by default, right? So of course, Ondat is there to provide this distributed storage replication, all those extra features. But more importantly, you need a database. So of course, operator to for developers to get database as a service is very important. That's one. And there's a second, which is also quite interesting, probably in relation to GitOps and all this notion of reducing the security sort of blast radius, I would say, is that, for example, if you create certain users or with certain permissions with an operator, if you try later on to modify them using like the database admin tools, it will revert back, right? So the single source of truth is still Git. So an operator is a way to control, to bring external systems like database and stateful application or anything into Kubernetes, but also into the component of Kubernetes, into the paradigms such as GitOps, such as policy, like Kyverno or Rego and OPA Gatekeeper. All those things that are applicable to Kubernetes becomes applicable to databases and or anything else. Of course, with Ondat, we're much more focused on stateful workloads, like in DoK, so that's database, message queuing, all of that. But sometimes something that is not necessarily, a bit overlooked is this kind of security and single source of truth aspect, which it is one of the benefits of the operator. But I agree, like for us, the main thing is around enabling database as a service for developer and bringing the developer into Kubernetes, because to be honest, like developers, they don't really care about Kubernetes. They don't want to manage Kubernetes. They have a love-hate relationship with YAML, and this is what we want to ask them. Just use YAML, and that should be enough.
At this point, I'd like to say something about the idea of operators in the context of database as a service. If you think about a company that needs to operate around, let's say, 1,000 Kubernetes clusters because they have a lot of application developers, like, pretty large enterprise. How exactly do you organize a database as a service? Do you put the operators on each cluster? Do you centralize operators on a cluster? And then compare that to, for example, a virtual machine-based solution that would integrate with a Kubernetes cluster based on a proxy CID. So something that will also create a service instance, but it will do that based on a VM. Because we have two products. We have the virtual machine-based automation, and we have the container-based automation. We see reasons to have both. But especially for large organizations, the economy of having a fully featured operator on each cluster puts a burden on the teams managing the Kubernetes clusters. And there is a break-even point where, well, let's say at least both Kubernetes container-based as well as VM-based automation could, have, their advantages and disadvantages. Just to say that, in my opinion, database as a service is still a problem, because if you think about a VM-based automation, again, you have an Amazon account or Azure account, doesn't matter. You install your automation, on-demand provisioning of dedicated service instances, again, assuming it's declarative, so pretty much the same paradigms apply. What's the end of that solution? It's the end of the quota within your infrastructure. So for example, the number of VMs that you can create simultaneously. It's usually hard to hit that. It's not impossible. We did that quite a few times. For example, in early days of the Frankfurt region in Amazon. But with the Kubernetes cluster, it's different, because then your first boundary you'll hit is when your nodes are full. So you also need to have some kind of auto-scaling mechanism for the Kubernetes cluster in place, because otherwise you'll hit that boundary way long before you actually come to the boundary of your infrastructure account. So you're back in the idea of on-demand provisioning virtual machines, just with the deviation of going through pods first. And I still believe in the long term, this is the way to go. But I'm saying, especially if you have a lot of clusters, you also have to manage the life cycle of your operators, assuming you install them a lot. So you're creating a lot of operational friction here. And there are problems yet to be solved to a sufficient degree. And I'm not a skeptic about operators. I'm an enthusiast. I'm just saying those are the pain points we currently see in some of our customer accounts. And this, maybe you guys have, you know, wonderful ideas on how to address that I don't see, but those are the things that, I don't know, painful to us sometimes.
No, and
we
to be
should
honest,
start.
like, I totally agree with that, and this is why I think we all think that there's a lot of work to be done there around the operator, especially when you want to use them at this kind of scale for, you know, specific like databases or this kind of things. Yeah, totally agree.
We should start a operator fan club here. You know, I think we have the first 3 members. It might not become a big community, but I'm sure we can.
I'm sure it will. It will.
Operator for life.
Yeah. For the virtual machine-based solutions, we've created a framework to automate data services, and we never shared this publicly, but we are doing that same thing again for operators. And you know, we are happy to join forces with others, because I believe the operator SDK, at some point it doesn't allow you to do enough, and at some other points it just doesn't do enough. So there's so much room for frameworks that support the automation of databases, and we haven't even got started here. That's at least my impression.
That's a very good bridge for me, Julian. The fact that you speak about perhaps joining forces or standard. For the same data on Kubernetes survey that we ran last year, 50% of the respondents say that their difficulty maintaining, and this word is hard for me to say, interoperability with operator. I did it. 42% complain about the quality. Some operators are great, some are not good because, well, no standard, and 40% of them say there is no standards, and that's the problem. And an interesting stat that really surprised me is that 61% of this organization said that they were building, like writing their own operator, like end users, which sounds, at least to me, not the right path to take. Sergey, do you have an opinion on that? Do you think operators are something that end users ultimately need to develop, or do you think that something that vendors or should take care of?
I think moving forward, once we form this club and have a standard approach to building the operators, then we would be saying, yes, companies and vendors need to build the operators. But right now, as we see the problem that quality issues are there, operators are non-standard. I have a couple of examples when we were working with big companies, which are running like thousands of servers for databases only. And they were researching how can they move their databases from their bare metal environments to Kubernetes. And definitely for these companies, they have tons of code around the existing solutions. They have tons of people working on these solutions, and it's extremely hard for them to transition to something which kind of limits their flexibility. Because going into the operator, you still have some limits, some boundaries. Of course, you can get at some point very, very flexible, but that would mean that you would need to rebuild the container images that are coming with the operator, or even play with the code and logic that operator has, or work closely with a vendor so that vendor would change the code and for you, right? And definitely the level of changes and the degree of changes that these companies required are really not matching our roadmap. So they want really hard specifics. They want, hey, we want this minor thing. We want this parameter to change, but you can do it like this. No, it doesn't work for this because we have this script somewhere that changes it and so on. So for them, this transition is extremely hard, and they start building their own operators in these cases. I also know that some cloud providers, like IBM, if you know IBM Cloud, they have their own operators to run their DBaaS. So once you click a button in IBM to run the database, something happens behind the scenes and the operator spins up the database. And they have their own operators. They build it for themselves, right? So definitely there are use cases, but again, once we get to the point when operators are standardized, we have good approach, good quality, then we can start pushing, hey, we have this operator, use it. Why do you want to build your own?
I think that, Julian, go for it.
This is a bit the story of automation in general. If you think about how databases are used within the enterprise, we have customers from various industries. Let's say the manufacturing industry on the one side and financial industries on the other side. You will see that they have vastly different patterns in using databases. Even if you take Postgres as an example, they're vastly different. And I mean, Postgres is a good example because Postgres is so versatile. You know, it lacks certain things that you'll have to add, like a proper cluster manager for replication. So there are so many countless possibilities on how to use it that the spectrum you will see in demand will, you know, the more people you ask, how do you use Postgres, the wider the spectrum gets. So if you as a software entrepreneur want to create automation, it's also important that you get the right customers in the right order, because otherwise you cannot make possibly any sense of your roadmap, because customers will tear you apart, right? The one is driving you in the direction, whatever, where you have offsite replication and all that. And the other customer, you know, doesn't care about that because he focuses on, let's say, rather low grade, cheap databases for developers to experiment with. And what we've seen over the years is that onboarding a new client, you know, may take up to 1 to 2 years before we've really understood their particular needs and gave them, let's say, those 5% of the features that they need, that their technical adoption can proceed. That's why we, for example, have a collaboration model with the client where the client can actually buy capacity of our development team to add those features to the automation in our product. Of course, there's, you know, this firewall to say, well, this is not in our interest, but in most of the cases, it's definitely unavoidable to adjust the software to the particularities of a large organization, because they have their policies, and otherwise the transitions would be blocked. Once this is done, you know, usage usually ramps up pretty quickly. But it's definitely one of the underlying problems in getting operators right is, you know, to find that 80% of features that, you know, or, you know, that most of the people actually require, and then leave the 20% to, you know, people writing their own operators and so on. But it's hard to get that done right.
Mm-hmm. You need the right level of standard, and obviously you cannot probably, as you said, Julian, cannot cover every edge case, possible edge case, especially for large organization. One way to see this operator and this gap, and it's really about, I think, Sergey, you said this at the beginning of our conversation, it's about day two, a lot of day two operation that you need to perform on your stateful systems. One of our members, Rick Vasquez, with the Senior Director Strategic Initiative at Western Digital, Rick wrote a very interesting article in the New Stack where he argued, perhaps, that's an opinion, that the integration with Kubernetes pattern, and I speak here about stateful systems, might have to be done by the vendor and directly into the product, which I think is an interesting take. Nicola, do you have any like opinion on that? Do you think this pattern is the right one? Do you think there could be something alternative that could perhaps you know, also like reduce the lag between vendor release on their product and then the operator like catching to it?
Yeah, I think it's operators. Currently, they are a mean to an end, right? So, of course, when it comes to software, the way you install software in Kubernetes currently, most of the time is if you want to have, things quickly done, you use Helm, and Helm will install an operator. So you manage all the Helm values of the operators directly when installing the software. It's not like Helm is replacing an operator. So I think it's quite common. I mean, I've seen it all the time. Instead of having Helm build your software and your logic, and installing all the, just basically the CRDs and without any operators, like it's installing the operators, and then you can influence what you have in your. I mean, you can influence the content of your custom resources. But so there is this. So it can be useful for software vendors to package it, and I think this is right. Like any software you want to provide in Kubernetes, if you want to apply best practices to your software in terms of data operation, management, scale, whatever, obviously operator, this is the way to go. But again, depending on, it's too broad at the moment. I believe we need like something between the operator and what vendors want to achieve. But on the other side, if you are an end user and want to do some automation, and you want to provide your own team or like enhance your internal IP, then yeah, of course, build like custom operator that are specific to your use case, your own company use case, because in the end, it's just another way to automate it, right? So there are two different angles, which are both if you want to automate things and provide IP for your own company, specific, very small, not small, but contained use case, perfect. You don't need a standard for that. But if we are talking about more like broader, vendor landscape, depending on what kind of software you want to sell and provide, then we need some more. I believe we need an extra layer that can, limit what you can do. Not necessarily limit, but put some boundaries and just get some standards there. Yeah.
I guess if you think about the future of database development for a second, because talking about vendors, I guess we are talking about database vendors as well. The question is, if you think about microservice in application architecture, and if you think that, most databases nowadays, people expect them to be distributed as well. So it's not enough to have, this is this one server database like Postgres used to be. And then you have to find your own cluster manager in that. I mean, who wants to do that? So modern databases, they tend to be distributed inherently. They have to solve complicated problems, and they may or may not have multiple processes to take care of all that. So the question is whether a vendor should use a standardized database automation framework of any sorts, and adapt that native to the product, so that a cloud native database in the future could inherently be built to be operated in a distributed cloud environment. And I believe if you look at the history of automation, earlier we mentioned Chef and Ansible and all the technologies, I call them DevOps generation 1. They have in common that they carried the heritage of human operators in their design. So the idea was that you have a physical or a virtual machine server, and you want to do to that server what a human person would do. And it was then data centers like Amazon who changed the paradigm in the data center first, like ephemeral VM and persistent disk. That whole thing was a game changer. And it laid the foundation for declarative automation with self-healing VMs or self-healing containers that later turned into, persistent volumes and all that, where you can separate the lifecycle of the VM or container from the lifecycle of the data directory that's so important to a database. And if you think that databases will be that start to be designed today, I mean, database research, I spent 2 years in database research myself. in my opinion, a lot of that database research is done by people, let's say, of advanced age. It's not necessarily that the database research embraces cloud to a fullest degree. There is a trend to do that. But let's give it another 10 years or whatever, or 5 years. I believe that database design will be different. It will be more cloud native. And if you also then look at the commercials, like the SSPL thing that, some database vendors now want to own the database as a service business entirely, excluding that from their open source. Like if you put that together, I think there's a fair chance saying that, the automation of databases will become inherent to the creation of databases to some sort, and that therefore vendors will play a large and important role in that. To what extent and exactly when this is happening is hard to predict, but I think the direction is already set.
Yeah, like how senior you are in the space matters a lot for human and database. Actually, MongoDB CEO, I think it's him who said like, yeah, you need at least 10 years to build a solid database. That was taken, that was a true thing, but maybe not a good thing to say from him, but definitely for stability and awareness, like experience, and therefore experience and time matters a lot. So I think kind of the summary that I hear from all of you is that we need some, and the words that were used were different, boundaries, standard, like something in between. So I think there is a consensus that there needs to be there is something to be done, and ideally we want something that could be used across the industry and could be open. So I'm going to ask this question to the three of you. Sergey, let's start by you. If I give you a magic wand, how would you start this standard or community? Like, what do you think is missing that could bring this to the next level?
I really love the point that Julian made about the cloud native databases, because I know how hard it is to build an operator for MySQL, which was invented in the 80s, and how easier it is. It's not easy, but easier a bit to create an operator for MongoDB, for example, which is in much better shape. So if I would have a magic wand, I would definitely incorporate this cloud native thinking into software development life cycles. Once you start developing something, think for the future, right? As we see, and we discussed today, Kubernetes is becoming a de facto standard. So it's going to be a control plane by default sometime later, and we want to make Kubernetes not so fun, right? We want to make it dull. And once we get to this point, once you have your product and you look at your product now, think about how this product is going to run on this platform of the future, how it's going to work. And definitely each developer should think about it.
Thank you, Sergey. Julian, what do you think? What, this missing piece, like, how would you shape it?
I think I have three things in my mind that popped to my mind immediately. Well, first of all, I would like to, collect general principles about automating data services. I wrote a script of a book a few years back, collecting the most important ideas, explaining, paradigms such as on-demand provisioning, how this relates to of dedicated instances, and how this relates to the ephemeral VM and the persistent disk problem, and how these two paradigms go together. So, get a basis for what actually data service automation nowadays is built upon, so that you have a view and a perspective on this that goes beyond technology, because Kubernetes is just another technology that will come and at some point it will go. to understand what actually caused the change and, you know, the next level, that those paradigms need to be understood quite, you know, substantially. Then once you have that basic understanding on the level of principles, I think of a more best practice guide where you think in the conjunction with a particular technology, how do you solve particular problems, let's say with Kubernetes? You need to translate those principles into best practices. And on this level, it's about having a more like a reference model to data service automation. For example, let's say you start with a fresh team, like good intermediate developers, you know, mid-aged people, some experience, good programmers, you know, have seen some data services, but not exactly the ones you want to operate. How do you get that started? And I believe you should have, you know, some, you know, training material and best practices. They need to get to understand the data service first, what problems that data service solves, what would a human operator have to do, right? So that needs to be understood to a sufficient level. And then you need to think about proper abstractions on how to get this into operation. And this is basically like the understanding of the data service and planning, let's say, how do I respond to network segmentations? Like, is there a leader election necessary? How do I test those edge cases that can really become problematic if you sell that as a software and you are liable? So get that on a best practice level right, so that, let's say, developers know what tests to write. And then the next thing is you want to back that up with a framework that already takes the heavy lifting away. For example, if you want to simulate a cluster failure in a split brain situation, that should be as simple as having a declarative test language saying that you want to have this, let's say, 5-node cluster split in the network, and you expect it to do this and exactly that. So those kind of things I think are important. So principles, best practices, and a proper framework that tie together. That is, I think, the future of operator development and data service automation.
Nick, do you have anything to add? I think it's...
Yeah, actually, it's kind of, yeah, I have the same idea. Not that I want to steal them, but yeah, I totally agree. And I would go one step further. And I think this is exactly this type of, you know, we need to encapsulate this into, if I had a magic wand, I would encapsulate all of that into a not like part of the Kubernetes API, but into an API provided more like natively into Kubernetes, such as how do you back up? How do you build your cluster? Is it sharding? Is it, you know, a cluster? All that in the same way that we have a CNI, you know, CS and a CSI that is done by, I mean, this is in tree, but here it would be something else, but that would be sitting by default, like, you know, kind of accepted by everyone, by the community, not the community and the users. Like you can, an add-on to Kubernetes, something you can install very easily that's meant for databases or stateful application. That would be a way to also state that Kubernetes is ready for stateful application. Proof is that we have this nice, you know, API where you can just plug in as a vendor. And on top of that, you have the, you know, the standard function like backup, fail, or detect failure, or react, or export. I mean, there's some of it in Kubernetes today with snapshot and cloning, these kind of things, but it's only like not even touching the surface. Yes. When it's databases, there's so much more. If you look at other solution, like I did like a DoK meetup this week in London around how to back up. It was Elasticsearch with Kasten.
That's a good one.
With Canister, right? So they have CRD that encapsulates what you want to do, and it's cloud native. It's just popping up containers and command lines. It's quite declarative, but we should bring this a bit like forward and so have something that is quite, you know, generic for all databases. Once we have this standardized API, then you can just plug in as a vendor and enforce your best practices and all these kind of things, right? So yeah, I think like it's really key.
I really love this idea. And, it's basically what I believe should be in the framework that I mentioned. So I think we are pretty well aligned here. However, the question is, if you think about such a thing, such an, an add-on or anything, basically there's the assumption that there is a common denominator in backups. And, I think one of the problems why this isn't there already is the way people approach data service automation. Like if it's very vendor-based, for example, you see a lot of companies talking about one data service alone. And this is not a good foundation to start, finding abstractions that could benefit the entire ecosystem. And there are rarely any company, automating many data services at once. And I think you really need to go through the automation of many data services to understand what backups actually are, because they are so vastly different, like data service can be. And therefore, it's hard to find a community schema that somehow describes what a backup actually is and how backups should be done. We had to learn that the hard way ourselves. For example, if you think about logical backups like dump and restore, and then you come to Elasticsearch where they say, well, why not take a snapshot? And then you're looking into point-in-time recovery where you have, like I say, a continuous stream of write-ahead logs or anything. Like they are totally different and require different communication protocols in backing up and in restore. And the question then would be, what's the best abstraction to represent those backups beyond, well, having a backup schedule and all that? Is it possible on a technical level to have a common framework, or would it more be like an adapter-based thing where you plug in strategies, so, right?
Yeah, I think adapter would be more like, think about it like a step function. At some point, you have to plug it in at the right level, right?
And if you think about that, you're basically already connecting to the other idea I was trying to get across, which would be operational models, where you think about the data service first. You would think, encourage the developer to think about, how can you do backups in Postgres? What are the different strategies you would go? And, make a conscious choice which one to select for automation. And also, like, think of a questionnaire or something like that gives you some orientation in like, is this more like this, or is it more like that? So that you have some guidance in development and don't run into all the traps like again and again. And that's why I think there should be multiple steps of abstraction and aiding automation so that people don't get lost.
Mm-hmm. So as we can see, even with 1 hour, or like, it's not enough to even come up with something like even just, we are just scratching the surface of how complicated this problem is. But we are reaching the top of the hour. Actually, this type of conversation is something that we do a lot at the DoK community. The community is made possible by our sponsors. Today, we had anynines, Percona, and Ondat. Thank you for being sponsor. That's what makes the community possible. If you like the conversation or want to be part of it, please consider sponsoring. This was Meetup 129. Julian, Nick, and Sergey, thank you.
Thank you for having us.
Thank you.
Thanks.
I appreciate that.
Thanks for watching. See you soon. Bye-bye.
Bye-bye.
Thank you. Bye.
Bart, we're done.
Great job, everybody.